Hello, today we're going to do lesson 15, calculating the surface area. Remember that the surface area is the sum of the areas of all the exposed faces. And this is the general formula that we're going to be using. The surface area, SA, equals 2 times the area of the base plus the lateral surface area, which is the perimeter of the base times height. So let's see the first example. It says, find the surface area of the rectangular prism. And they give us a drawing like that. And the rectangular prism, we could use this same formula that is given here, but there's even an easier way to do it. And so in math, we always look for the easiest way to do things. And in this case, what we want to do is find the area of this front face. Then we want to find the area of this side face. And then we want to find the area of the top. And then realize that each one of those has a partner. So the front face has a back face, the top face has a bottom face, and the side has another side here on this side. So what we can do is find the area of each one of them, add them, and then multiply times 2. So to find the surface area in this case, we're going to find the area of the first one, the front, which is 5 by 10. We're going to add the side, which is 8 by 5. And then we're going to add the top. Now, what are the dimensions of the top? Well, it's the 10 that is down here and the 8 that is here. So 10 by 8. And all of that, we're going to multiply times 2 because there are 2 of each one of those. And so in this case, we have 50 plus 40 plus 80 times 2. So we get, in the parentheses, 170 times 2, which is 340. And the exercise tells us that the units are centimeters. So since we're looking for area, is the square centimeters. In the second example, they're asked to find the surface area of this right triangular prism. So we're going to find the surface area by using the formula that was given at the beginning. 2 times the area of the base plus the perimeter of the base times the height. So what is very important is that we realize that the base is the triangle. Now, how do I know? It's not because it's standing on it, but it's because the bases are always parallel to each other. And if you see here, these are the only 2 faces that are parallel to each other. The other faces are intersecting each other. Also, in a triangular prism, the triangular is giving us the idea of what is the base, and the 2 bases can have different polygons, different shapes, but the other ones, the lateral faces, have to always be rectangles. Okay, so now that we have that, let's start by finding the area of the triangle, that is our base. So in this case, it's going to be base times height divided by 2, and the perimeter is adding all 3 sides and then times the height. So let's substitute the values. The base is going to be 3, the height is going to be 4, and then divided by 2. Notice how that height is lowercase and this height is capital, because the height of the base is going to be lowercase and the height of the solid is going to be capital H. Then we add 3 plus 4 plus 5 times the height, which is 10. And if we simplify that, this is going to be 12. And then this is going to be 12 times 10. Remember, order of operations tells us to do that first, the multiplication. So it's 120 plus 12. And the answer is 132. And in this case, the units are meters, so square meters. In the next example, they are asking for the surface area of a right circular cylinder, and that's the shape of the cylinder. Now, they say that the radius is 5, so this is 5, and the height of the cylinder is 12, so this is 12. So we use the same formula, and remember that we have to use the area for each one of the bases. So in this case, the base is a circle, so we use the formula for the area of a circle. And then for the perimeter, we use the formula for the circumference of a circle. So now we just have to substitute the values. And in this case, they say that the radius was 5, so it's 5 squared pi. And then the circumference is 2 times 5 times pi, and the height in this case is 12. So we got 2 times 25 pi and 10 times 12. And then just to finish this, we have to multiply first and then add. So we have 50 pi plus 120 pi, which is 170 pi. And that would be the surface area of the cylinder. And in this case, the units are inches, so square inches. Let's go to our last example. In this example, they give us another cylinder, but it has a base that is very irregular. It is one of those bases that we have worked with before, that is a square or a rectangle and a semicircle. So we're going to use the same formula, but we have to use now the specific formulas for the rectangle to find the area of the rectangle and also the semicircle. And the same with the perimeter. We have to find, or we have to add the straight parts, but also the curve. And then all of that times the height. So in this case, we have to multiply the dimensions of the rectangle, which are 6 by 8. And then add the semicircle, the area of the semicircle, which in this case, since this is 8, the radius are 4. So 4 squared pi divided by 2. And then we're going to have to also add these straight parts, which is 6 plus 8 plus 6, plus the 4 pi, that is the semi-perimeter. And all of that times the height, which is given in the word problem here, which is 12. And then we simplify all of that. 6 times 8 is 48, and 4 squared is 16, divided by 2 is 8 pi. And then this other part, we can only add the like terms. So 20 plus 4 pi, we can't combine those two because they're not like terms, because they don't both have pi. And then in this case, we are going to do distributive property to get rid of the parentheses. So it's 96 plus 16 pi. And the same here, we are going to multiply times 12, both of them. So 12 times 20 is 240. And 12 times 4 is 48 pi. And then we add like terms. 96 plus 240 is 336. And 16 plus 48 is 64. And in this case, the units are feet, so square feet. And that's it. That's our last example. All right, have fun.